All right, Robert. I've heard weird things. I've heard not all cores are created equal. I've got two new types of cores I've never heard of before: E cores and P cores. I'm assuming they stand for energy efficient cores and performance cores. Is that right?
Yeah, we're done.
We're done. That's it. That's
Yeah,
it. That was
that's it.
easy.
That's it. Now, the question, why?
Yes. Why? Why are we having multiple cores now?
Yeah, that's important because just as no core is exactly the same, no one customer is always going to be exactly the same as the other. No one workload is going to be exactly the same as the other, and no one customer's business dynamics or technical considerations are exactly the same. So why have we done an E core and a P core, an efficient core and a performant core? Just as we've learned over the last couple of generations in client computing, we sometimes have users that are going to really need to use performance cores to get their jobs done. We want to give them that option. We have other things that need to be done that we just don't want to blow up the battery life case, right? We don't want to have to haul around a 5-6 pound laptop. We want to get it smaller by being able to do things on a more efficient basis. We've known that for a couple of generations. We've been building that into the personal computing environment. In the data center, it's the same thing. We need to be able to balance what customers are actually trying to do. And different types of customers need to do more of very high density, lower power, efficiency cores, okay, in what they're trying to design for their applications or their customers. Versus others, they're really more the traditional. They're trying to get the most performance out of a core. That's the P core. Now, with that, that means we pack in less cores than in the efficiency cores. In the E-core based systems, we pack in a tremendous amount of cores, and we let the customers kind of make the choice as to what they value the most: performance per watt density versus performance per core and dollar over here on the P core. It's our challenge
So,
to help them understand why they're going to make those choices.
so the P core is more performant. It also has a full list of accelerators in the P cores, where the E core is not as many accelerators. Is that how it works then?
Correct. Our P core is more akin to our traditional lineup where we've been implementing lots of capabilities, hyper-threading, our way of doing simultaneous multi-threading, but hyper-threading, it's where we've been bringing in built-in accelerations or accelerators, like if you remember old things like AVX512 and VNNI and now Intel AMX and QAT all into the P core lineup. They'll move forward. Those same kind of technologies, because the design criteria is really to bring the power down, and lots of cores without those other features. Okay, for density reasons, that's in the E-core lineup. So we really have to understand what the customer is trying to do. What are their workloads by which those accelerators or built-in technologies beyond the very many cores and the clock frequencies, where do they really need to live versus what can I do over here with more of that efficient core, very large amount of cores in the E-core lineup?